Section 2.2, Linear Inequalities in one variable. In this section, we are going to solve linear inequalities, double linear inequalities, linear absolute value inequalities, and applications of linear inequalities. If the equality symbol in a linear equation is replaced with strictly less than or equal to, strictly greater than or equal to, the result is a linear inequality. The solution of a linear inequality consists of some interval of real numbers. The solutions can be described graphically or with interval notation. Cancellation properties for inequalities. Assume A, B, and C represent algebraic expressions and D represent a non-zero constant. The first one, if the expression A less than expression B, then the sum of expression A and expression C is still less than the sum of expression B and expression C. The second one, expression A less than expression B and the quantity D greater than 0 or the positive sign value, then the product of the expression A and the positive value D is less than the product of the expression B multiplied by the positive quantity D. Another way we say the inequality symbol does not change. The last one, if the expression A less than expression B, then the quantity D is less than 0 or negative quantity, then the product of expression A and the negative quantity D is greater than the product of the expression B and the negative quantity D. That means the inequality symbol will be opposite if you multiply by the negative quantity. Let's solve the following inequalities and use the interval notation to describe the solution set. In part A, we have the expression 4.2 times x minus 5.6 strictly greater than 1.6 plus x. When you solve, that means you are going to solve for x or isolate x terms in one side. We have x terms in both sides, so we're going to collect them together in one. So I'm going to subtract x both sides of the equation, of the inequality, and then we're going to have 4.2x minus 1x, that becomes 3.2x minus 5.6 as a constant greater than 1.6, and then we're going to add 5.6 both sides because we are going to isolate the x term by itself on the left hand side. So this way we are going to get 3.2x by itself as this side, and then the right hand side, which is the sum of 1.6 and 5.6, we get 7.2. Next, we're gonna make the coefficient of the x to be 1, so we divide both sides by 3.2. This case, we divide by the positive quantity. The inequality symbol will not change to the opposite one, so it will remain as the strictly greater than inequality symbol. At this step, we're going to have x greater than 7.2 divided by 3.2, which is 2.25, or we can write it as x is strictly greater than 2.25 as the result of this inequality problem. And then we're going to use the interval notation to describe the solution set. This one, since x is strictly greater than, if you look at the real number line, for the 2.25 greater than, that means going to be on the right side of the 2.25. Strictly, that means we don't include that number. This is the graphical way to represent the solution set, but in the interval notation, we just imitate this one by starting with 2.25 strictly greater than. That means we put the open parentheses, and any number on the right side, we use the notation positive infinity to represent the interval notation to describe this solution set. So this one is the graphical way. This one is the interval notation. Let's look at the example B. We have the expression on the left as 5 minus 2 times the quantity x minus 3 less than or equal to negative times the quantity 1 minus x. First of all, we are going to expand the left expression and the right expression, and then we're going to collect like terms after that. So the left-hand side becomes 5 minus, and then distribute 2 to the parentheses, becomes negative 2x plus 6 less than or equal to negative 1 plus x, and then collect like terms on each side if it's available. So the left hand side, we have 5 and 6 as the like terms, so we combine to be 11 minus 2x less than or equal to negative 1 plus x. And after that, we're going to collect the x terms together. It's convenient to move into the term that has positive inside. It doesn't matter you move to the left to the right, we just do it. We have to treat it appropriately. So this way, if I add 2x both sides of the inequality, that means the x expression will be on the right side of the inequality symbol. Now we have 11 on the left less than or equal to negative 1 plus 3x. And then we're going to leave 3x by itself. So we're going to add 1 both sides. So we have 3x on the right side with the less than or equal symbol, and the left number gonna be 12. And next we're gonna divide all by 3. Since 3 is positive number, so we do not switch the inequality. We got x on the right side with the less than or equal to symbol, and then 12 over 3, that is 4. Or we can write in the form that is in common as x is greater than or equal to 4. With this way, we transform into the graphical way. Where's the number 4? First, right here, x greater than, that means we're gonna point the arrow to the right side. Equal to, that means we include the number 4. So we have the solid dot. And then in the interval notation, gonna be the square bracket, and then 4. And anything greater than 4, we use the positive infinity symbol and open. So this one is the interval notation, and this one is a graphical notation of this solution set. Another example for this example set, the expression on the left is y minus 6 divided by 7 greater than or equal to greater than or equal to. The expression on the right is the 2y minus 1 all divided by 3. In this case, if you have the rational form, it's convenient to get rid of it by multiplying by the common denominator. For this problem, the common denominator, or the LCD, is the product of the 7 and 3, which is 21. So multiply both sides by 21. When you multiply by positive number, the inequality symbol does not change. And I fill in the parentheses here with the original expression of the left and the right hand side. And this way you can see that the denominator will be reduced and cancelled. So the left expression becomes 3 multiplied by the quantity y minus 6 greater than or equal to the quantity 2y minus 1 multiplied by 7. And then the next step, we just distribute the value into the parentheses. the left-hand side becomes 3y minus 18 greater than or equal to 14y minus 7. And next, we are going to solve for y by collecting the y terms together in one side. 3y and 14y. 14y is greater, so we're going to keep 14y where it is and subtract 3y both sides. So this way, we have the left-hand side as negative 18 greater than or equal to 11y minus 7. And next, we're going to leave 11y by itself. So we're going to add 7 both sides. Now we get 11y on the right side with the greater than or equal to symbol in the middle. And the left number is negative 11. So now we're going to leave y to make y as the one as a coefficient. So we divide both sides by 11. Divide by positive number, the inequality symbol doesn't change. That will give us y on the right side greater than or equal to symbol in the middle and negative 1 on the left. Or we can rewrite it as the order in common as y is less than or equal to negative 1. And then in the graphical way, locate negative 1 less than or equal to gonna be on the left side. We include negative 1 gonna be the solid circle. So this is the graphical way to represent the solution set. And then for the interval notation, negative 1 as the right end, including we have the square bracket. Any number lower, we represent it by negative infinity symbol and then open parentheses. So this one is the interval notation that represent the solution set of this problem.